Titan, an Oceangate-operated submersible, vanished on June 18, 2023, in international seas in the North Atlantic Ocean near Newfoundland, Canada. The founder and CEO of Oceangate, Stockton Rush, was one of 5 people inside the submersible on a tourist mission to see the RMS Titanic debris. The U.S. Coast Guard and Canada's Coast Guard attempted a rescue, but were unsuccessful due to the projected 3 days of oxygen supply. Until early on June 22, when signs of the ship's debris began to surface, it was tragically determined that there were no survivors, and the ship exploded in the ocean's depths. According to what is known about the business that runs the Titan and submersible, Oceangate Incorporated, based in Everett, Washington, sells inexpensive submersibles for use in exploration and research, as well as the tourist sector. Guillermo Solon and Stockton Rush launched the business in 2009. Stockton Rush obtained his commercial pilot's license to fulfill his dream of becoming an astronaut, but due to poor vision, he could never serve as a military pilot. To work at McDonnell Douglas as a flight test engineer for the F-15 Eagle, instead relocated from San Francisco to Seattle. In 2004, he decided he didn't want to go to space as a tourist and instead wanted to be like Captain Kirk on the Enterprise after seeing the launch of Spaceship One in the Mojave Desert. He changed his focus from land to underwater exploration because he wanted to explore. He was married to Wendy Rush, whose ancestors Isidore and Ida Strauss perished in the sinking of the Titanic, which is relevant to the current narrative. The fatal incidents occurred during a deep-sea tourist mission to examine the Titanic's ruins, which sank in 1912 in the northern Atlantic. Let's think about the difficulties of deep water research before we get into the specifics of this particular catastrophe. Because defying gravity and soaring through the air looks so amazing, it's simple to be in awe of aviation and space research. However, deep water vessels provide a far larger technical challenge. Everything is determined by pressure. Because the air pressure at sea level is so low, 14.7 pounds per square inch, we rarely consider it. The air column that extends above us into space causes that pressure. That pressure is caused by the same molecules pushing down from above us. However, compared to air, water is a considerably denser liquid. In other words, the pressure rises by 1 atmosphere, or 14.7 psi, for every 10 meters, 32.8 feet, or depth you descend. On the ocean floor, roughly 12,500 feet below sea level, is where the Titanic is currently located. After spending more than a century at the bottom of the ocean, the ship's bow and stern are still damaged and separated by more than 2,600 feet of wreckage. Put this depth in its proper context. At 100 meters, the length and width of a soccer or football field, or 145 psi, we have a pressure of 10 atmospheres, or how much weight you would feel on a board measuring 1 foot by 1 foot. This implies that we would feel the weight of 20880 pounds on the 1 by 1 foot board. Regarding Tesla models, that is 4.7. The height of the Empire State Building in New York City is 381 meters, 1250 ft. We would experience a pressure of 37.4 atmospheres at this level, and each footboard would feel the weight of 80,000 pounds. The maximum dive depth for U.S. Navy submarines of the C-class is 490 meters. Here, we would experience a pressure of 48.5 atmospheres, and the 1 by 1 foot board would feel 800 pounds. We have the Burj Khalifa's height, which is 828 meters. Here, 82 atmospheres would be felt. That would be 173,520 pounds of weight on the board. This is around the same depth as the deepest diving submarine currently in service, the Russian Navy's Oscar-class vessel. The Titanic's wreckage is 3,800 meters above sea level, where the pressure is 376 atmospheres, making our chest weigh 797,000 pounds if each footboard were placed one at a time. For a mass dive depth of about 4,000 meters, the Oceangate Titan was rated. That may sound absurd, but James Cameron is the most spiritually profound person ever. The Deep Sea Challenger, constructed in Australia, reached the Pacific Ocean's Mariana Trench's deepest point in 2012. The mind-boggling 11 meters or 36,000 feet deepest place on Earth. The pressure would be 1090 atmospheres, and the 1x1 foot board would weigh 2.3 million pounds. When flying at a cruising altitude of 36,000 feet, the pressure outside the aircraft may be 3 psi, while the pressure within the aircraft may be between 10 and 12. It could help put things into perspective as to why more individuals have traveled to space than the deepest regions of our oceans. Let's discuss how we arrived at the Titan. In 2012, Oceangate began by acquiring the submersible antipodes. This served as their initial testing ground for this entire endeavor. Then, in conjunction with the Applied Physics Laboratory at the University of Washington, they constructed Cyclops 1. Additionally, this ship could travel to a maximum depth of 500 meters in deeper waters. This was their next step and development. However, it was still far from deep enough for the Titanic. The original concept called for a carbon fiber hull, and the submersible would plunge vertically with swivel seats to keep the passengers upright. We'll return to the claim that Boeing collaborated with Oceangate and the University of Washington on their first design analysis, since that narrative has more to it. The final product, rated for 4,000 meters, would finally reach the Titan. One of the most important things to remember about the Titan is that it is a submersible made of titanium and carbon fiber. In the world of materials, this is exotic. High-strength steel and aluminum have been used for a long time, and we have data engineering data on how they fail, what to look for, and test methodologies. However, carbon fiber is still quite exotic. It's unlikely that any car you've ever driven contains much carbon fiber. The main exceptions are extremely expensive supercars and, more recently, the Boeing Dreamliner in aviation. However, before that, we used materials like titanium and aluminum. Therefore, there is often less knowledge about it, and ensuring you do it correctly is also quite challenging. Oceangate and Spencer Composites entered into a contract for the carbon composite cylinder in January 2017. In January 2018, Oceangate's Director of Maritime Operations, David Lockridge, submitted a quality control report, claiming that no non-destructive inspection, or NDI, of the carbon fiber hull had been done to look for voids or delaminations that may weaken the entire structure. The non-destructive investigation, or NDI, is the easiest method to determine whether something is secure to cut it in two or otherwise damage it. Still, NDT non-destructive testing allows you to do this without doing so. It says, yep, it's safe, but the product has been ruined. Engineers so frequently rely on NDT to guarantee that things are secure. And because carbon fiber doesn't bend, give, acquire grooves, or fracture the way other materials do, it's much harder in the world of carbon fiber. It calls for a lot of knowledge and understanding. Oceangate will rely on a real-time acoustic monitoring system. Lockridge was informed. He believes this would not give the crew enough time to cancel the mission and return home safely. The day after he filed his report, he was summoned to a meeting where he was told the acrylic window that you look out of was only rated for 1,300 meters because Oceangate would not fund the design of a window rated for 4,000 meters. In that meeting, he reiterated his concerns and added that he would refuse to allow crude testing without a whole scan. Lockridge was dismissed from his position as a result. Oceangate filed a lawsuit against Lockridge that June, accusing him of improperly sharing proprietary trade secrets and fraudulently manufacturing a reason to get rid of him. The case was resolved in November 2018. I'm sure everything was kept confidential, and we'll never know the specifics of what was decided, but that could be better. Stockton Rush utilized the vertical thrusters on December 10, 2018, to overcome unexpected positive buoyancy when descending below 10,000 feet. Since these submersibles are filled with air like a balloon, they have difficulty diving. They have many methods and ballast systems to do this, but for whatever reason, he had to utilize vertical thrusters to continue his drop at about 10,000 feet. And when this occurred, it disrupted everything else, including the communication networks between rotating propellers and the water trail left in their wake. They were out of touch for an hour. Rush was ecstatic to announce that, after James Cameron, he was the second person to solo dive to a depth of 13,000 feet. And thanks to that reporter's account, we now know what happened again. In January 2020, after these tests were finished, the Titan started to exhibit symptoms of cyclical exhaustion, and its rating was reduced to 3,000 meters. After being restored, the hull was given a new rating of 4,000 meters for diving depth. But was everything carried out correctly? You can't possibly know. We're on the cusp of a new era of exotic travel and discovery, whether deep sea diving, space travel, or visits to the moon in low Earth orbit. We're about to witness more wealthy individuals engaged in this occurrence. We always want the next thing. Therefore, if we do this, we must know how dangerous it may be. This is a particularly difficult topic since open waters must be better monitored. We are quite ambitious. That implies we must construct our vessel from 5 inches of carbon fiber. However, one must also understand how crucial safety precautions and protocols are. There is none of that happening here. One of the first things to recognize about a vessel implosion is that there was probably not much pain involved. Rather, the victims likely passed very instantaneously. You can see that we already indicated how heavy it would be down here, and you would be destroyed. So what occurred was that they constructed a ship, which was already rather spectacular in and of itself. It had a titanium composite frame and was a strange craft, and there was a window where you could see the Titanic. These are things that humans were unable to achieve in the past. The issue is that every machine, and technical item has a useful life. Engineers do this by evaluating a product to determine how many cycles can be applied before issues arise. And then they add a safety factor. How long did the Titan remain in service? It was ever determined that they weren't performing non-destructive inspections or NDTs to check on the carbon fiber. This vessel just had a diffractor distortion or a little crumple. They did successfully go down and come up 3 times, but on the 4th attempt, they collapsed, so clearly something was occurring for a few cycles. Any ship that travels to the Mariana Trench or a depth of 12,000 feet in the Atlantic should, in all honesty, have a lifespan of several cycles or more. The goal of Stockton Rush was to keep these tickets reasonable. Although this is unfortunate, we must constantly learn from our errors in engineering. These individuals took the risk of their own volition and with knowledge of the risk. They may have known what this vessel was, but to what extent? Did they fully understand the risk, and when? Most likely not. Therefore, they are areas where we can work to improve, and perhaps the next time someone has the bright idea to explore the deep ocean. Think about how much more expensive it will become because superior methodologies are already used. I hope you guys will like and share this video. Thank you very much for your lovely comments. See you in the next great video.